We're on 4.6 homework assignment in the textbook, looking at inequalities and equations, specifically those that have no solution or all real numbers can be the solution. So looking at number 2, if we add negative 12y to both sides of this inequality, so let's first write it down. If we add negative 12y, which is the same as minusing 12y, to both sides, what inequality results? So for part A, our answer right here, we're going to get this cancels, 11 greater than this one cancels, and we get negative 1. So this is the inequality that results. 11 is greater than negative 1. That's a true statement. So for letter B, we can say any real number, all real numbers, however you want to write that out, that's fine. But since this is a true statement, it's any real number or all real numbers. And if this was not true, if it said 11 is less than negative 1, then there would be no solution at all. All right, we're going to solve these sentences. Number 5. I'm going to go ahead and distribute. And you notice 4 ends on both sides. So we're going to go ahead and cancel it out. And we're left with negative 6 is greater than 44. That is not a true statement. So there are no possible solutions. And again, what that means is it doesn't matter what number you plug in. There's no number that I can plug in that makes this true. Number 6. I'm going to minus 65w on both sides, leaving me 0 on this side, equals 11. 0 does not equal 11, creates an untrue statement, so there are no solutions. Now this one you can see is exactly the same on both sides. So we already know this is going to be any real number or all real numbers. But if we're going to show the work, we're going to go ahead and eliminate an x value, and it'll eliminate on both sides. You get 33 equals 33. That's a true statement. And so any real numbers are part of the solution. You can plug any number you want in for x, and both sides will come out equal. Just think about it. No matter what you plug in here, you're going to times it by 12 and add 33. Same thing on this side, so clearly you're going to get the same thing on both sides. It doesn't matter what number you put in. Any real numbers produce a true statement. All right, we're going to distribute here. And I could have done it over here earlier, but these can be combined like terms. So that's 27d. So I have a variable on both sides I got to eliminate. So I'm going to go ahead and do that. They're both going to go away, and I'm left with 6 is greater than 0. It's a true statement. So any real number is a solution. Number 9. One of these population questions. So we're starting at 40,000 and growing by 800. This one's starting at 200,000 and is growing by 800. So every year they're both adding the same amount of people, but they're both starting at very different places. So for letter A, what will the population of Yorkville be in Y years? So Yorkville is starting at 40,000 and it's adding 800 per year, and they want Y for the years, so Y looks like that. Letter B, what's the population of Newburgh? So 200,000 plus 800Y. And for part C, when will they be the same? So you're going to set these two equal to each other. Now, just thinking about it, you should know they're never going to be the same. They're starting at different numbers and they're increasing by the same amount. So as one goes up, the other goes up the same amount, so they're never going to be the same. But we're going to show it algebraically. We set the two populations equal to each other. When we look at this, we see there's a y on both sides of the equation, so we want to eliminate one. But they both eliminate when we do that. And we get 40,000 equals 200,000. That is not true. And so there is no solution. When will their populations be the same? Never. All right, and then jumping down to number 13. We have to distribute first, so we get negative 15p minus 6. Pretty straightforward. We're going to add 6. So negative 15p is greater than 30. Divide by negative 15. Now, when I divide by a negative, I have to flip. So p is less than negative 2. 14. So when I simplify the right side, I have to distribute this negative. So let me bring this down. Negative 1 times n is negative n. Negative 1 times 4 is negative 4. And that's the little piece right there that everybody gets wrong. They put a plus sign there, but you have to distribute that negative. You're minusing the n and minusing the 4. Now you can combine like terms. You've got a negative 7 and a negative 4. That's going to be a negative 11. Still have minus n. All right, we've fully simplified both sides. N's on both sides. Let's eliminate the smaller of the two. So I'm going to add n to get rid of this. So I have to add n on the other side. So I get 3n greater than or equal to negative 11. And then I'm going to divide by 3. Positive 3, so no flip. N is greater than or equal to negative 11 thirds. Not a nice decimal, so we're going to go ahead and just leave that a fraction. All right, 15, we're sending a package. It's $3.50 plus 25 per ounce. This other one is $4.75 plus 10 cents. If your package weighs 16 ounces, which service is cheaper? So let's go ahead and just plug it in. So $3.50 plus 0.25 per ounce. So if we're weighing 16 ounces, we're going to plug that in. And then the other one is $4.75, but it's only 10 cents per ounce. So we're going to plug in 16 right there. So we just got to run our numbers here. So 25 cents times 16 comes out to 4. So $3.50 plus 4 is $7.50. And over here, 10 cents times 16 is going to be $1.60 plus $4.75. Gets you a total of $6.35. So this one is going to be cheaper, and it says explain your reasoning, but if you show your work, you don't have to explain. And let's go ahead and actually answer the question. It's broke fast. Company that is cheaper. So on number 16, Mama's Pizza charges $12 for a large pizza and then 90 cents per topping, and Pizza Palace charges $14 for a large pizza and 40 cents for each additional topping. Number A, write an equation for each pizza shop describing the cost of a large pizza in terms of the number of toppings. So C equals, cost equals for both of them. So for Mama's, it's 12 plus 90 cents per topping, and we are using T for toppings. This is Mama's. And then the other one, Pizza Palace, 14, but it's only 40 cents per topping. So that's A. Those are my two equations. For how many toppings are the pieces equal? So we're going to set these two equal to each other. And I'm going to be careful with my handwriting and make sure my plus sign looks different than the T. So when do they cost the same? When are they equal? So we're going to solve this equation. I've got a T on both sides, though I need to get rid of one of them. Let's get rid of the smaller one. So 40 cents T is coming off of both sides. So I have 12 plus 50 cents T equals 14. I'm going to minus 12. And that's going to get me 2 on that side. I'm bringing it over here. So 2, 50 cents T. I'm going to divide by 50 cents. And T equals 4. So the answer is 4 toppings. And the last one, number 17. Looking at presidential election numbers, so fitting to what we were just dealing with here in the country. So this many people voted, and then in the next election, this many people voted. That's an increase, but we want to know what was the percent did it increase. So what you started with is your 100%. You're comparing everything back to that. It went from there, and it went up to this. So we want to know what is this, what was the change. So we're going to go ahead and subtract. So I get 1, 6, 8, 9, 6, 6, 9, 1. So it was a change of a little more than 16 million. So that's the amount that it changed, but we want a percent. By what percent did the number of voters increase? So it's always based on what you started with. Started here, changed by this much, what percent was that, comparing those two? So we're going to write an equation, and we're going to say that 16, 8, 9, 6, 6, 9, 1. We want to know this is what percent of this. So this is what percent of this. And so we're going to divide. A little tedious writing all those numbers. And this will give us the answer. Now you can always set this up when you're comparing a piece to a total. You can just divide. We showed it with an equation, but you can jump right to this knowing that I'm comparing this to this. So you put it over the top and you divide. And you're going to move that over. It doesn't say to the nearest percent, but you can see it moves over to 16.03, and that's close enough to 16% that we're just going to stick with that. And we did round it. We want to indicate that a little bit, so we're going to say about 16%.